Artificial intelligence has seen a huge leap across the board. Google DeepMind recently solved a critical weakness in chatbot reasoning. Now, rather than being misled by flashy, meaningless content, these systems are beginning to prioritize truth, logic, and relevance. Meanwhile, in China, scientists upgraded a basic math AI into a high-level reasoning engine that rivals some of the most advanced models in existence. Over at Meta, the company just assembled a billion-dollar lead AI team made up of experts from OpenAI, DeepMind, and Anthropic. Microsoft also joined the momentum by developing a medical AI that diagnoses patients with 4 times the accuracy of human doctors. No joke. And if that wasn't impressive enough, Xiaomi unveiled smart glasses that outperform Meta's Ray-Ban models, featuring voice interaction, instant translation, and even glance-based payment tech. Clearly, AI had an explosive week. Let's unpack it all. Let's begin with a major breakthrough from DeepMind. The company addressed a core issue in how chatbots evaluate responses. AI systems are generally trained to give outputs that people find satisfying, relying on something called a reward model to decide what counts as a good answer. But here's the catch. Those models often misfire. They might reward answers just because they're lengthy, pleasant-sounding, or look polished, even if they're inaccurate or unhelpful. To solve this, DeepMind collaborated with researchers from McGill University and the University of Montreal to build a system named CROME, short for Causally Robust Reward Modeling. What sets it apart is its approach. Instead of feeding the model random examples, they taught it to distinguish between what actually makes an answer strong, like logic and truthfulness, versus surface-level traits like politeness or verbosity. They accomplished this by designing answer pairs. In some pairs, they altered key details, like factual correctness, called causal augmentations. In others, only the tone or phrasing changed, leaving the facts untouched. These were neutral augmentations. By exposing the model to both types and training it to respond only when the quality truly shifted, the model became better at focusing on substance and ignoring fluff. The team used Gemini 2.0 No Flash to produce these training examples and leveraged a top-tier dataset called Ultra Feedback, shaped by real human preferences. To evaluate CROME, they ran on 3 language models, Gemma 2 9B, Quinn 2 5.7B, and a smaller Gemma 2 2B. The models faced several tests: Reward Bench, which checked ranking performance; Reword Bench, which inserted misleading tweaks to test focus; and Wildcard Test, which assessed safety under risky prompts. The outcome? CROME significantly improved model accuracy, especially in safety, which rose by about 13%, in reasoning, which climbed roughly 7%. Even when the evaluations attempted to trick the model with clever formatting, CROME performed more reliably than traditional reward models. When presented with several answer options, it also showed improved ability to avoid unsafe outputs without becoming overly cautious or conservative. So, what's the main conclusion? CROME trains AI to prioritize what genuinely matters in response and filter out superficial distractions. That could make the next generation of chatbots significantly more useful, honest, and secure. Okay, let's rewind a bit. Remember how self-driving vehicles seemed like pure science fiction back in 2019? Today, over 400,000 Teslas operate autonomously each day. And while most people weren't paying attention, the use of AI across industries skyrocketed by a massive 270% in just 3 years. Businesses that were once doubtful are now seeing 15% higher productivity compared to their peers. According to McKinsey, AI is expected to add $13 trillion to the world economy by 2030, but it will also require 375 million people to transition into new job roles, many of which will demand strong AI capabilities. That's why I'm personally inviting you to a free, exclusive 2-day live AI training by Outskill. It's normally priced at $895, but it's currently 100% free for my community. And no, this isn't some dull, passive lecture. It's 16 hours of engaging, hands-on learning happening Friday from 10 a.m. to 1 p.m. Eastern Standard Time, and continuing on Saturday and Sunday from 10 a.m. to 7 p.m. Eastern Standard Time. You'll dive into prompt engineering, explore over 20 powerful AI tools, automate your daily tasks, analyze complex data with zero coding, apply AI in Excel and PowerPoint, generate stunning videos and images, create software tools without writing a single line of code, and even develop your own AI agents. This experience is crafted for professionals across tech, business, sales, marketing, HR, and more. People from over 40 countries have already enrolled. And if you're serious about keeping up with AI's rapid growth, you definitely should join too. Just click the link in the description to reserve your free spot now. Also, don't forget to join their WhatsApp community to stay updated. The opening session kicks off this Friday at 10 a.m. Eastern Standard Time. Don't miss it. Now, while Google DeepMind concentrated on aligning AI responses more closely with human values, researchers at Shanghai's Zion University, working under the project OctoThinker, took a different approach, amplifying raw reasoning ability. Their target: pushing models to solve complex problems, especially in mathematics, using structured step-by-step logic, often called chain-of-thought reasoning. We already know that models like DeepSeek R10 and Simple RL benefited from reinforcement learning when trained to reason in sequential steps. That strategy showed promising results with the Qwen model series. However, applying the same technique to models in the Llama family led to strange behavior. Rather than improving in accuracy, the models started producing overly lengthy responses, sometimes stretching to 4,000 tokens, without any real gain in correctness. So, the team concluded the issue wasn't with reinforcement learning itself, but rather how the base model was initially trained. Their solution? A two-stage training approach they dubbed stable then decay. Their solution involves a two-step training strategy they refer to as stable then decay. Initially, they trained the system using 200 billion tokens comprised of premium math-focused data from a curated collection known as MegaMath Web Pro. After this primary training reaches a plateau, the model is divided into 3 separate variants. Each continues learning on around 20 billion tokens, but with distinct categories of mathematical and logical problems. This set of models was given the name OctoThinker, since each variant emphasizes a unique style of reasoning. The long variant maintains all the step-by-step logic. The short one simplifies it, and the hybrid seeks a balance between the two. Essentially, they gave the AI 3 different learning methods to test which one yields the best outcome. All 3 were evaluated against several established math challenges: GSM 8K, Math 500, Olympia Bench, and even the 2023 American Math Competition. Consistently, every OctoThinker variant surpassed the original Llama model by a margin of at least 10%. The long version even achieved parity with Qwen, a model well regarded for its strong performance in sequential logical reasoning. The standout advantage: OctoThinker avoided falling into the usual trap of lengthy and cluttered responses. It provided crisp and relevant answers, while the base Llama tended to produce rambling outputs under reinforcement learning. The scientists argue this proves that if the foundational training is solid, reinforcement learning can build on that in a productive way instead of amplifying noise. Looking ahead, they aim to enhance OctoThinker with features like integrated scratch pads and math validation tools. They're also advocating for more extensive and cleaner math datasets, since most current ones don't exceed 100 billion tokens. Their ambition is to develop models capable of robust reasoning immediately, without needing later-stage patchwork training. Meanwhile, buzz about these more capable models has triggered a wave of hiring as Meta forms an AI superintelligence division. Mark Zuckerberg recently revealed Meta's superintelligence labs in an internal note that later became public. This new team consolidates all of Meta's cutting-edge AI projects, and the company committed several $billions to recruit Alexander Wang away from Scale AI, awarding him the Chief AI Officer title. Former GitHub CEO Nat Friedman also joined as a partner, along with 11 senior AI researchers from Anthropic, Google DeepMind, OpenAI, and other top organizations, reportedly drawn by compensation offers in the tens of millions. Meta also explored potential acquisitions, including Mira Murati's Thinking Machines Lab, the search startup Perplexity, and Ilias Sutskever's Safe Superintelligence venture. However, none of those talks resulted in firm deals. Within the memo, Zuckerberg noted that the lab will begin building the next generation of models in the coming year, indicating Meta's intention to leap ahead rather than merely keep pace. In the escalating talent competition, this influx of top minds from companies like Anthropic and DeepMind gives Meta's comeback real credibility. Meanwhile, Microsoft is taking a different direction, focusing on healthcare. The company announced that its AI surpass human physicians in diagnostic tasks, using this as proof of concept for multi-agent collaboration. Mustafa Suleiman's AI team introduced the MAI Diagnostic Orchestrator, dubbed MAI DXO, calling it a meaningful stride toward medical-level superintelligence. The coordinator functions similarly to a panel discussion. It prompts multiple major language models, including OpenAI's GPT, Google's Gemini, Anthropic's Claude, Meta's Llama, and xAI's Grok, and then merges their responses into one cohesive diagnosis strategy. The developer selected 304 authentic case reports from the New England Journal of Medicine to create what they call the sequential diagnosis benchmark. This benchmark mimics the traditional clinical workflow. Observe symptoms, choose relevant diagnostic tests, assess the outcomes, and repeat until a correct diagnosis emerges. On this benchmark, Mid-Axo achieved nearly 80% diagnostic precision, approximately 4 times the performance of a group of doctors who were not allowed to consult outside sources. Even more impressive, the orchestrator reduced expenses by about 20%, thanks to its preference for more cost-effective tests and labs whenever feasible. MIT's David Sontag and Eric Topol from Scripps applauded the study's thoroughness, but also noted that true validation demands a real-world clinical study, where AI and medical professionals go head-to-head on live patients. Microsoft has yet to finalize any product rollout, but rumors suggest possible Bing integration for self-diagnosis features and clinical tools that may streamline patient intake. To construct this advanced system, Microsoft quietly hired top-tier AI scientists away from Google, highlighting the fierce competition in the field for elite talent. Meanwhile, on the hardware front, innovation isn't slowing down. At the Human Car Home event in Beijing, Xiaomi introduced their AI-powered smart glasses, joining the wearable tech race. These glasses incorporate their proprietary Super Xia AI assistant and are powered by a Qualcomm AR1 chip along with a Hang Swan 2700 coprocessor. A 12MP ultra-wide camera enables the wearer to take photos or record first-person videos. The glasses also support real-time text translation and object recognition. Users can even approve Alipay transactions using just eye movement and voice input. The battery has a 263 mAh capacity, offering up to 8.6 hours of runtime, more than double the lifespan of the Ray-Ban X Meta collaboration, which maxes out around 4 hours on a smaller power cell. Audio is delivered through open-ear stereo speakers, and voice control is handled via 5 built-in microphones. The frames weigh 40 grams and have an IP54 water splash resistance. The arms can flex outward by 12 degrees and tilt forward by 5 degrees, a shape optimized for typical East Asian facial structures. Electrochromic lenses darken within 0.2 seconds after a double tap on the side. Available color variants include classic black, vibrant parrot green, and a semi-transparent tortoiseshell brown. The base version is priced at approximately 1,999 yuan, or $280, while the upgraded version with photochromic lenses goes for around 3,000 yuan, or $420. Compared to Meta's sleek but short-lived Ray-Ban collab, Xiaomi's glasses offer double the usage time, voice-first interaction, and novel pay-by-glance feature. Still, their debut seems aimed at China's domestic market, with no clear indication of a global launch just yet. So the big question remains, will all this tech genuinely enhance AI's usefulness, or simply boost its power without purpose? Share your thoughts below. Like, subscribe, and stay tuned for more updates. See you in the next one.